Welcome to This Explainer. Today, we're going to absolutely shatter a massive misconception that's currently sweeping through the energy industry. If you track utility-scale battery energy storage systems, BESS, you probably think you know exactly what's holding back these massive projects. But I'm here to tell you, based on the latest data, we are all looking in the totally wrong place. Let's pull back the curtain and expose the true hidden bottleneck that is quietly dictating the pace of the global energy transition.
Okay, let's dive into this. The hidden grid bottleneck and the misdirected obsessions in the energy sector. So, the entire industry is suffering from a severe case of tunnel vision right now. Literally, everyone is obsessing over battery cell pricing and container availability. Go to any conference, read any industry report, and that's the whole shebang. And it kind of makes sense, right? Batteries are obviously the core of a battery energy storage system. But the true critical path has quietly shifted to interconnection hardware. While development teams are frantically negotiating pennies off cell pricing and tracking shipping containers, the actual timeline of these utility-scale projects has completely stalled out. The real challenge isn't getting the batteries, it's physically connecting them to the grid.
Which brings us to the anatomy of the delay. Let's look at the unseen culprits.
So, the crucial point is that this isn't just some vague logistical headache. We are talking about highly specific, deeply technical hardware components that are quietly, but absolutely, killing project momentum across the board. The ultimate bottlenecks dictating your project velocity come down to three specific components: high-voltage underground cables, heavy-duty switchgear, specifically gas-insulated switchgear or GIS bays, and substation expansion slots. You can have all the battery cells in the world sitting on your lot, but without these three vital interconnection components, your massive energy storing system, it's just a very expensive paperweight. These are the physical bridges between your energy asset and the wider power grid, and right now, securing them is becoming a monumental hurdle.
30+ months. I want that to really, truly sink in for a second. We aren't talking days or weeks here. That is more than 2.5 years of waiting just to secure these vital interconnection components. To put that into perspective, you could almost finish a law degree in the time it takes to just get this hardware delivered.
Think about the sheer operational pain here. Imagine sitting on shovel-ready land while waiting years for custom transformers and GIS switchgear bays. Imagine the frustration for your engineering teams. You've done the hard work, right? You've navigated the complex zoning laws, you've secured a fully permitted multi-megawatt site, the land is completely shovel-ready. But that massive achievement means absolutely nothing if you're just stuck in a queue for custom transformers.
This directly causes a huge financial fallout. This is what happens when shovel-ready becomes stranded capital.
Because, look, this isn't just an engineering or scheduling problem anymore. This is a severe financial crisis impacting development teams on a massive scale. Across key European and North American grid nodes, vital hardware shortages are literally turning fully permitted pipeline assets into stranded capital. Developers in both Europe and North America are bleeding capital because their perfectly viable energy projects are entirely paralyzed by the lack of heavy-duty grid infrastructure.
Let's break down exactly how this delay translates into balance sheet devastation. First, project financing. It creates a massive stranded capital lockup. Millions of dollars are tied up, generating zero return. Second, COD schedules. Because of this, commercial operation dates are pushed back by years, completely upending revenue projections and investor agreements. In the third piece, asset status. The tragic result is having assets that are fully permitted by regulators, but entirely paralyzed by the supply chain. You get the green light from local authorities, but a massive red light from the hardware manufacturers.
And this brilliantly illustrates the tragic irony of our current situation. We're treating grid connection hardware as an afterthought, when it's actually the ultimate bottleneck, dictating project velocity. The industry has spent so much time obsessing over the batteries themselves that it neglected the very physical components required to make the project actually function. Basically, the afterthought has become the main event.
But we can fix this. Here are 3 mitigation strategies for front-running the bottlenecks.
Let's move to and see how this builds, because this explainer isn't just about admiring the problem, it's about solving it. Highly successful engineering teams aren't just sitting around waiting for 30 months. They're deploying 3 strategic mitigation approaches to change their project sequencing. Step 1, they secure grid connection components incredibly early, way before the land is even shovel-ready. Step 2, they integrate this procurement directly into their initial site design during early project development. And Step 3, they specifically front-run supply chain delays by moving hardware from an afterthought to the absolute first item on their checklist. So I want to leave you with this final, provocative thought. For the project developers and EPCs tuning in, how are your teams working around these multi-year interconnection delays? Are you still obsessing over cell and container pricing, or have you restructured your procurement to front-run the true grid connection bottlenecks? Because the teams that figure this out are for sure the ones who will successfully power the energy transition. Thank you so much for joining me, and I highly encourage you to take a really hard look at your own critical path today.